class, welcome back to our YouTube channel once again. And this is actually example 2 of what the Thevenin's analysis. Okay, we are always saying that the Thevenin's equivalent is represented in this form, where we have the Thevenin's voltage. We call it what? ETH. In series with what? ZTH, and then finally in series with another one, which is the load what? Impedance. Okay. This is how the Thevenin's equivalent is being represented. So here we know that the ZL has been given. So ZL is actually equal to what we have here, the 7 ohm and then this. So we are removing the whole of this system off. That becomes our load, right? So it means that the value of ZL, right, will be the combination of what we have taken off. Now let's rewrite it well. So it means that if we are to draw this circuit for the equivalent, it's going to be like this. Positive minus, and we'll have our VTH, okay, multiplied, and then we have this one in series with it, which is the what? ZTH. Then we'll have what we are taking off, that's the load. So here we have, let me write it well. So we have the 7 ohms here, and then we have finally the last one, which is the main source. So we'll have plus minus 30 angle what? 15 degrees. This is what we have. So what are we looking for? We are looking for what? ZTH and VTH. That's our main focus. Okay. We know that what VTH is what? The open circuit what? Voltage. So let's do that. So we'll have this one here, 10 angle 0 degrees. And then we'll have this one. I want to represent it in what? In its impedance form. So let me call that one Z1. Z1 will be equal to 6 plus what? J8. 6 plus what? J8. Okay. That's Z1. And then we'll have this one, this side to be in this form. So that's Z2. We call 3 minus J4. 3 minus what? J4. That's what we have here. And then finally we'll have the other side, which of course the only parameter there is what? J what? 5. Okay. Because that's an impedance. And the rest becomes open circuit. So we'll have our VTH. And VTH is simply the open circuit one voltage. If it is open circuit, it means that the current doesn't pass here. That means this one is not going to contribute to anything. Okay. So it means that the voltage here will be the same as the voltage here. We can even take this one off. So and this one is a series power, but current does not branch to the other side because it's open circuited. Right. So we are going to find the voltage here. We can use voltage divider. So the voltage across, so let's call this one Z2. This one was Z1. The voltage across the Z2 with the same as what? VTH, right? And it's given by the voltage division of what? Z2 over Z1 plus what? Z2 all multiplied by what? The voltage, which is what? E. Okay. So that is what we have. Now it means that the value of what? VTH or ETH, okay, will be equal to. So we know the value of what? Z1, okay. Z1 was given as what? 6 plus what? J8. And then Z2 was given as what? 3 minus J4, right? So it means that what? This value Z2 will be 3 minus J4, right? All on Z1. Z1 is 6 plus J8 plus Z2, which is what? 3 minus J4, which will give us what? A corresponding value of what? Which will give us what? Corresponding value of 5.08 angle minus 77. So you can use your calculator to do it. You just send it to complex numbers and point the whole of this and change it to what? The radius with its argument. Okay. So that's the parameter for what? VTH, right? Let me just put the circuit back there again. So what other parameter are we looking for? We are looking for the value of what? ZTH, right? So the same thing. Let's redraw the circuit. Okay. Okay. So we'll have So and then we know that whenever we are drawing for ZTH, we assume, right, that no ZTH. We say that anytime we are looking for ZTH, if it is a voltage source, it becomes what, short circuited. If a current source, becomes open circuited. So this is a voltage source, so it becomes what, short circuited, and then we can represent that side by the impedance alone. That's 6 plus what, 8 what, J. So Z1, our Z1 is there, and then we'll have the other one, which is what, Z2, okay, which is given by 3 minus J 4. 3 minus J4. Okay. So this is what we have. Now this is going to be our VTH. Don't forget we had another resistance there, inductance there, which is what, J5. So here I always say that anytime we are looking for ZTH, okay, anytime we are looking for ZTH, right, we assume there is a current moving from here. So if there's current moving, means that what this and this is going to be in parallel, and then going to be in series with this, right? So let's solve it. So parallel means what? Z1 parallel what? Z2 plus, since it's in series with what? J5. Okay. And then I'll solve it from there. Now that will give us 6 plus J8. Put that over sum, right? Z1 comma Z2, which is what? 3 minus J4, right? 3 minus J4. 3 minus J4, all divided by the sum. 6 plus J8 bracket, right, plus 3 minus J4. All this multiplied by all this plus J5, and that will give us a corresponding value of ZTH, right? ZTH is equal to 4.84 ohms plus J 2.94, which can also be in the form of an angle, right? That will also work. So that can be the same as what? 5.41 angle 32 point what? 35. You can always use a calculator to convert this. Okay. Now it means that what, let's look for we've already found ETH, right? So I want to represent the equivalent circuit diagram, and that will be this. The equivalent ETH was given as what? Was given as 5.08 angle minus 77.09, right? And then we'll have our ETH, right? ZTH. That's also given by 4.84, the one we just found, plus J 2.94. Okay. All this with the what? With the load. Of course, we know the load is what? 7 ohms. And then we'll have our positive, negative here. That's 30 angle 15 degrees. So this becomes what? The end of what? The question. Thank you very much. If you have any problem, you can put it on the comment section for us.